No. I want to simultaneously review a couple of the things that we talked about the other day for completing the square. And then at the same time, I'm going to help you, we're gonna come up with a simpler way, the simplest way of solving quadratic equations that otherwise are hard to solve. Okay, so this is gonna be the way that you probably use most often. It boils down to really, you don't have to, you got a whole bunch of different choices, but a lot of those choices effectively go away when you're presented with an easier option like this one. Okay? But understanding how it works and how we develop this other option really comes from completing the square. So they're related. All right, so first of all, completing the square. Let's do a quick review here. Completing the square. Remember, our goal with completing the square was always to start with two terms, x squared plus bx, and add to those two terms just the right number so that we could create a perfect square trinomial, right? Which would factor into a perfect square. That's the whole point, is to come up with a perfect square, starting with x squared plus bx, okay? So what was the number then that we had to add to those two terms to create the perfect square trinomial? Yes, ma'am?
1.
Well, not 1. It might in some cases be 1. But in general, if this number in front of x we're going to call b, yeah, did you remember? Yeah.
It's you just divide by 2 and then square it.
That's it. Yeah, it's just whatever that number is, so b over 2 squared. That's it. Okay, whatever that number ends up being, that's the number we need to create a perfect square trinomial. And if we do that, if we add that term to the first two and create this perfect square trinomial, what is it going to factor into? The quantity what squared? Yeah, that's it. X plus whatever that number is, quantity squared. Okay, it always follows that pattern. Okay, so let's use that. So here's an example of a problem that it doesn't matter. The new trick I give you is not really going to help you on this. On this, we've got to come up with, the goal here is to take the original quadratic function in standard form or general form and to rewrite it in vertex form. So first of all, remind me what is, and you really got to know these. At this point, I would expect that everybody knows these. So what is vertex form? Y equals, what are the coordinates of the vertex first, I guess? What are the letters we use for the coordinates of the vertex? What is it? H and K. There you go. So it's equals what then? We always start with A, don't we? A times what? X minus, good. Which one, H or K? H. Quantity. Okay, plus K, you're right, but there's one little thing we're forgetting there. Squared. Right now that's linear. Right now there wouldn't be any x squareds in there, but now there are, right? And so you can see the purpose for that, completing the square probably then, right? We've got to come up with, somehow we've got to come up with this perfect square. That's a part of vertex form. So we need to get a perfect square out of our original quadratic function in general form or standard form, right? Okay, so what are we going to do? What are we going to do to this then? We're starting with, here I'll rewrite this. We're starting with y equals x squared minus 6x plus 19. What do I need to do? Which side am I probably going to complete the square on? Which side of the equation, the right or the left? The right side, aren't I? I'm going to do it on the right side because that's the side that's got dx squared, right? Plus bx. What's b in this case? Negative 6. Good. Okay, so we need to start with just that stuff, right? So what do I probably want to do over here? Got too much stuff on the right side. I don't want that 19, do I? What do you think? Yeah, subtract the 19 off to the left side. We'll just store it there, right? So on the left side, we'll end up with y minus 19. On the right side, we're going to get x squared minus 6x. Well, there's our x squared plus bx, right? So what's our b again, you told me? B is negative 6, good. So what's b over 2 going to be then? Negative 3. So what's the number that we're going to add to both sides then? Okay, and it's going to look like, over here it's going to look like, we want to write it in the form b over 2 squared, right? That's what you told me to do up here, right? So b over 2 would be negative 3 squared. And the reason I would write it that way instead of as a 9 is because then on the right side, it's easy to factor that into the perfect square. It's just going to be x plus whatever that number is, quantity squared, right? Okay, but we got to treat both sides equally because it's an equation. And so if we added this number to the right side, we also have to treat the left side equally and add it to the left side to keep it balanced, the equation balanced, right? So what's the number that we're going to end up adding to the left side then? 9, right? Negative 3 squared is the same thing as positive 9. And here we want to think of it just as a number so we can combine like terms. Make sense? Okay, question? All we did here was we added the same thing to both sides to keep the equation equal. Okay. Now we added it to the right side for a purpose, because on the right side we wanted to get this perfect square, but we still got to keep track of what we've got going on the left side also. Okay. So when we simplify the left side, what do we end up with here? When I combine like terms? Yeah, good. So just y minus 10. And on the right side, we got what we needed. There's our perfect square, right? That's a part of vertex form right there. We got that. So all we have to do now is just get that y by itself again, like it is in vertex form, and we're done. What's the one step we need to do to get the y by itself? Add 10, right? So we just end up with y equals my perfect square, x minus 3 squared, plus 10, right? So our vertex has what coordinates then? Yeah, positive 3, positive 10. Everybody agree? And what's the value of A? 1. So does it open up or down? Opens up, right? That tells us a lot about our parabola, doesn't it? Okay. All right. What if we want to do a little harder one? I want to do one of these. I'm going to have you do one of these too. Now, what about something like this? This is a little bit tougher because to get this into the form that we need it, right, to complete the square, x squared plus bx, it's not just a single step this time, is it? I got to do 2 steps. So if I'm trying to isolate x squared plus bx on the right side, what are the 2 steps I'm going to do to set up the right side to complete the square? First, I'm going to do what?
Divide by 2.
Okay, I'm not going to do that first. First, I'm trying to isolate these 2 terms on the right side of the equation, and so when I isolate, I reverse order of operations, correct? So the first thing I'm going to do is add or subtract. Add 23, okay? That make sense? So we're just going up the order of operations to isolate some terms on the right side. So we add 23, step 1. Y plus 23 equals 2x squared plus 12x. Now remember, we have to get x squared plus some number times x on the right side. So what's the next step that we have to do? We've got to divide by 2 because we've got to get rid of that 2 in front of the x squared, right? So step 2 would just be that, right? So what are we left with? Now on the left side, there is no reason to try to simplify this, none at all. Because ultimately, we're just going to undo that stuff and get the y by itself anyway, right? remember that the left side is just a place that we're using as kind of a storage area. We're just storing some numbers on that side that will later on move back to the right side. But we got to get the right side cleaned up so we can complete the square. So we end up over here with just our plain old y plus 23 over 2. On this other side, dividing an expression by a number, by a common denominator, is the same thing as dividing each individual term by that same number, right? I could split this into separate fractions, couldn't I? So what's the first fraction going to simplify to? X squared, like we needed, right? So we get x squared, and what about the second one? 6x, okay? That worked out pretty well, didn't it? Doesn't always work out so nicely, though. In this case, what's our b? Not 6x, just 6. Okay, so if b equals 6, what's half of b? 3. Okay, but sometimes it won't be so nice. Sometimes we'll get things like this. What if b is equal to, for example, what if it equaled 11? What's b over 2? Okay, but we probably want to leave it as a fraction. And so it's just going to be 11 halves. That's okay, it can be a fraction. What if b equaled a fraction already? What if it equaled 3/5? Now what's b over 2? Well, we don't have to. It's easier than that. Remember, dividing by 2 is the same thing as multiplying by 1/2, isn't it? What do you think? It's 3/10, isn't it? Because it's just going to be the same thing as b times 1/2, which is 3/5 times 1/2. And multiplying fractions is easier than adding. Just multiply straight across, right? So we would just end up with 3/10 for b over 2. It's a fraction, but that's okay. It could be a fraction. Hopefully we'll, we'd rather it weren't, but, oops, I didn't want to do that. But sometimes it is. Let's get rid of this. Go back and finish our problem. So where were we here? Let's see, we had that. So we wanted to add to both sides then. We figured out what b over 2 was. It's 3. So what's the number I'm going to add to both sides then? No, what am I going to add to both sides here? Okay, what's coming next? I got to create a perfect square trinomial. Remember, we always want to add half of b squared, right? So we got the x squared plus bx by itself on the right side. What's half of b? 3 squared. So 3 squared. So on the other side, I've got to add the same thing, so I'll add 9 to that side, right? Okay, everybody agree? So now on the right side, that's what we needed. We created our perfect square trinomial. So that's going to factor into what perfect square? X plus 3. Okay, and I can probably trim that down a little bit. Okay, on the right side or the left side, I've just got kind of a jumbled mess, but that's okay. We're just going to get that y by itself. Yes, sir.
Where do the x squared and 6x go?
Okay, well, if we think about this in terms of factoring for a second. If I expanded that out, that's just x squared plus 6x plus 9. If we were going to factor this, we'd have to come up with two numbers that multiply to 9 and add to 6, right? What would those magic numbers be? 3 and 3. So this would factor into x plus 3 times x plus 3, which is just x plus 3 squared. So by adding this number out here, we're always going to create a trinomial that factors that way. Okay, but we don't even have to think about it in terms of magic numbers. We always know that whatever that number is that's being squared, x plus that number is going to be the factor that's squared. Okay, does that make sense? Okay. Okay, so then on the other side, let's just write the y in red, because that's what we, whoops, not blue. Let's write it in red so it really sticks out. this is what we're going to try to isolate then. All we've got to do, we've got our perfect square like we needed, right? Now we just need to get rid of all these other numbers. To get the y by itself. So we're trying to isolate y, so that means we're going to reverse order of operations, correct? So we just know that we're going to follow PEMDAS backwards, which, what do you call it, SADMEP? So we're going to do SADMEP. So what are the steps in order to get that y by itself then? First we subtract 9, then we multiply by 2, then we subtract 23. And we got the y by itself, right? That's it. Now, it's not coincidental that those 3 steps, aren't those just the reverse of the order that we did our first 3 steps? Right? So the last thing we did was add 9 to both sides. So the first thing we'll undo is 9. We'll subtract 9 first. Right? The second thing we did was divide both sides by 2. So that's the second thing we'll undo. Right? And then the very first thing we did was add 23 to both sides, so subtracting 23 is the last thing we'll undo. Make sense? We're just undoing the steps that we did in reverse order, by reversing order of operations. Okay, so what do we get when we do that? Step 1, if we add 9 to both sides, we get our subtract 9, sorry. Y plus 23 over 2 equals that, right there. Minus 9, right? Next, we multiply both sides by 2. So the 2's cancel, right? And we end up with, on the left side, y plus 23 equals. Now, what do I do on the right side? I have to multiply the whole right side by 2, and there are 2 terms there. So what's that mean? I've got to distribute, don't I? I've got to distribute the 2 to each of those 2 terms. Now, I can't, even if you wanted to, you can't distribute the 2 inside that quantity because it's being squared, right? That's not even an option for us, but we don't want to anyway, right? That undoes our goal anyway, because our goal is to get a perfect square, right? So we don't want to undo the perfect square. We want to leave it as a perfect square. So we end up with 2 times the quantity x plus 3 squared, right? And doesn't that just look like a times the quantity x minus h squared, right? And then 2 times negative 9 gives us a negative 18. One last step, what is it? Yeah, subtract 23 from both sides, right? And we end up with y equals 2 times the quantity x plus 3 squared, and what's negative 18 minus 23? And so we got it, right? We got it, okay? What are the coordinates of our vertex this time? Yeah. Negative 3, negative 41, a equals 2, so it opens up. How about that, okay? Now, we're kind of stuck completing the square whenever we need to write a function in vertex form. But when we're just trying to solve an equation, we could complete the square to solve this. Right now, it's our only option because we can't factor that, right? And there isn't a single x for us to isolate. By completing the square, we could create a single x that we could isolate, right? To do that, wouldn't we just add 1 to both sides and then divide both sides by 3? Agreed? And we could do it that way. But wouldn't it be nice if we could come up with an easier way that would prevent us from having to do all that algebra every time? Okay, there is a way. And I'm not so concerned, honestly, that you know how to do this. as much as that you understand why we do it. Okay, so here's, I want to just kind of talk to you about what it means to come up with a formula in math. Because this is a big deal. We use formulas a lot, but you probably never think where they come from. What is a formula, first of all, in math? What does that mean to you when we talk about a formula? Say it again. Okay, kind of. I mean, isn't it just, it's sort of maybe an equation, but it's going to be some expression with some variables in it. We're just going to plug in numbers for the variables to find some quantity that we need to know. It might be if we're trying to, there's formulas for people use them all the time. If you want to know how many board feet of timber are in a Douglas fir tree, if you measure the distance around the Douglas fir tree, there's a simple formula that says if the circumference is this, then that translates, if I plug this into some little formula and it translates into this many board feet of lumber. If you want to know what the resistance in a circuit is, you just make a few measurements and plug it into a formula and you find out. There's always formulas that you end up using, lots and lots. Everybody uses them all through life. So where do they come from, though? Now, think about this in terms of starting with a general equation and solving it generally. Now, we just looked at an example that we could do, right? We could do this problem by adding 1 and dividing by 3 and starting off on the left side with x squared. If we did just that much, right? Well, I'm not going to do this problem, but if I just added 1 to both sides, divide both sides by 3, right? That's supposed to be a 3. Then we just end up with x squared minus 2x equals 1/3. And now I could complete the square, right? Agreed? We're not going to do it, but we could. Couldn't I do that same process with something like that? What if we start with a situation where there are no numbers that have been specified? The numbers in this equation are a and b and c, but we never said what they were. Now, the power of that is, the problem with that, not the problem, but what makes that a little difficult is it's harder to combine, to simplify things. When I have numbers, I can add the numbers up and get just one single number maybe. Here I can't do that because I don't know what the numbers are yet, right? But the power is, if I can solve this equation one time in terms of a and b and c, then the answer that I get is going to work for every situation, isn't it? If I just knew in a specific situation what a and b and c were, like for example here, a is what? 3, b is -6, c is -1. If I could just identify what those values are, whatever answer I get, when I solve this equation, plug those numbers into the answer, and that's it, right? That's the beauty of a formula. So what's this look like? Well, I'm not going to, I've done this every period, and I don't know that it really is that useful just to walk you through all the algebra. We'll take a quick look at it, and you can just kind of see that you could do it, right? If I subtracted the c to the other side and divided both sides by a, I could start off with x squared plus some number, b over a times x on the left side, right? If I add half of that, if I add half of that number squared, which is just b over 2a, quantity squared, to both sides, I create a perfect square trinomial that factors into that, okay? So on the left side, I got a perfect square that only involves x's and a's and b's, right? On the right side, if I get a common denominator, multiply top and bottom of this second fraction by 4a over 4a, I get a common denominator, and I can combine like terms. And you could all do this, really. Now all I have to do, I've completed the square, all I have to do is just square root both sides and subtract that term from both sides, and I've got a formula, right? If I square root both sides, on the left side it gets rid of the squared. On the right side, we just get the square root of the top over the square root of the bottom. Square root of the top we're kind of stuck with. That's not going to simplify. But the bottom, I can square root. The square root of 4a squared is just the square root of 4, which is 2, times the square root of a squared, which is a, right? And so look, I've actually got common denominators now. right? And so when I subtract this other fraction to this side, look what we end up with. We get our, well, we're going to put it in front of the plus or minus, aren't we? Right? I should have done that. We get our negative b over 2a plus or minus this radical over 2a. So I've got a common denominator. I can write the whole thing in terms of a common denominator. And this is what we call the quadratic formula. Okay? That tells us if we start here, if we have a quadratic equation in standard form, in the form ax squared plus bx plus c equals 0, got to get 0 on the other side, then the solutions are always given by that formula. Two of them. One for the plus sign, one for the minus sign. Okay? And so doing quadratic equations, or solving quadratic equations, is just a matter of plugging the values into the formula and simplifying it a little bit, getting an answer. Easy, right? Much easier than the alternative. Does that seem like kind of a hard formula to remember, though? A little bit? I'll help you out. Help you out here. 5 minutes from now, you will not be able to forget it. Yeah, you heard that, huh? You're right. You could. No, it'd be better if it would.
Dude, this is funky.
Hi, boys and girls. Are you ready to learn the quadratic formula side? Cool.
That guy's
X equals negative b plus or minus square root b squared minus 4ac
I hate you.
divided by 2a. Isn't this fun? This is great. Let's try it again. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Let's do that again. Let's try and make it a little bit different. I don't know. Make it a little rockish. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Cool. Maybe we could sing it a little bit faster. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. That was fun. Let's try it a little bit slower. X equals negative b plus or minus square root
It is.
b squared minus 4ac divided by 2a. Oh, that was so nice, so sweet. Let's just sing it one more time. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Divided by 2a.
Okay, now my research shows me that if I play it twice,
God damn
you
it.
never forget it.
Funky, guys.
Are you ready to learn the quadratic formula? X equals negative b plus or minus square root b squared minus 4ac
Let's hear it.
divided by 2a. Isn't this fun?
Yes.
Let's try it again. X equals negative b plus or minus square root b make it a little bit different. I don't know. Maybe a little rockish. X equals negative b plus or minus square root b squared minus 4ac divided by 2a.
How would you not notice that?
Cool. Maybe we could sing it a little bit faster. X equals negative b plus or minus square root b squared minus 4ac.
I don't even remember.
Divided by 2a. That was fun. Let's try it a little bit slower. X equals negative b plus or minus square root b squared minus 4ac divided
Too
by
many.
2a.
Yeah, no.
For you.
That was so Let's just sing it one more time. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Divided by 2a.
Okay, I won't make you listen to it again.
How many views does this have?
I don't know. It's
Check. You can literally check right now.
where do I go to check reviews?
Escape.
Oh.
234,000 bags.
Yep. How about that?
Don't do it again.
No. Oh. But before the end of the year, I'll have to. I can't pick a favorite though. That'd be like picking my favorite child.
No.
I can't do that.
No.
Wait, don't you only have one child?
Yes. Okay, well, I just want to show you how to use this thing. So, up here. All right, so we got this quadratic formula now. So when we want to solve an equation like this, all we have to do, we got to remember it, right? So what is it?
X equals
God damn it! Shut up! Very nice. All right, there we go. Okay, and you got to remember that's what we get if we've got a quadratic function in standard form to start with, right? Those are our solutions. Okay, so all we have to do, if we want to solve one like this example over here, then let's just kind of section that off. What's our value of A? 5. What's our B? What's our C? Okay, so if we want to come up with the solutions, then we know that x equals that, right? And you can sing it all you want when you get home. A equals this. Hey, this with those numbers substituted, and then all we have to do is simplify it. So I'm going to show you 2 ways of doing this. There are going to be 2 assignments related to this stuff. One of them is mostly going to ask you to give me exact solutions to quadratic equations. So that would mean I want, for example, square roots included in your answers if there are square roots, because those are exact answers. The other one is easier. The other one is just going to let you give me decimal answers. Okay, and I'll show you a way on the calculator to do this really quickly and efficiently. Okay, so plug these in. We get negative b in this case is what? Negative 3. It's just the opposite of b, isn't it? So if b is 3, negative b is just negative 3, plus or minus the square root of b squared. What's that?
3 squared is 9.
Good, 3 squared, so 9. Now write it this way. Minus 4 times in parentheses a, in parentheses negative 1, all divided by 2 times 5, which would just be what, 10? Okay. Here's why I like you to write it this way. All you have to do then is count the number of negative signs, because you've got a product of 3 numbers here. This time we have 2 negative signs. Whenever I multiply an even number of negative numbers together, what is the result always guaranteed to be? Positive. If I multiply an odd number of negatives together, I'm always guaranteed to get negative result. Okay? So then you know that this is going to be, when I simplify this, and that's all we have to do is just simplify this, I'm going to get negative 3 plus or minus the square root of 9 plus. Because I have an even number of negative signs, I just find that product. 4 times 5 times 1 is 20. See? All divided by 10. And so we just end up with then, there's really not much to do in this case. Negative 3 plus or minus the square root of 9 plus 20 is 29, all over 10. So there's some things that could happen here. It could happen that I get something under the radical, a number that I can simplify. Maybe I get something like the square root of 50 there that I could write as 5 times the square root of 2. So maybe I can simplify that. This time I can't. 29 is prime. So this time I'm just stuck with that the way it is. Moodle is going to ask you to enter your solution. If multiple solutions exist, separate them with a comma is roughly what it's, I don't know, that's word for word, but that's what it's going to tell you to do. There are multiple solutions here. There's one for the plus sign and there's one for the minus sign, right? So if we use the plus sign, we very simply get the solution, negative 3 plus the square root of 29 over 10, put a comma. If we use the negative sign, we get negative 3 minus the square root of 29 all over 10. Those are exact solutions. Completely exact. We used square roots. But if you're going to use, if decimal answers are okay, here's what you can do. If decimal answers are allowed, I could just, let's pull up a set of parentheses here to go around. We're just going to simplify this whole thing. Actually, let's go up a little bit. Let's simplify this thing right here. I could just put a set of parentheses around the whole numerator and parentheses around the whole denominator and just use parentheses. Or if I want to, I could even use the fraction template. Makes it even easier. If I go alpha F1, enter, I can pull up a fraction and make it look just like this, right? So I've got negative 3 plus square root. You can't do plus or minus. You have to do them separately. But I'll show you a way to do it real easily.
How do you
Square.
do plus or minus?
Say it again.
How do you do plus or minus? Or is that just
You
plus?
can't. It's just plus.
You just go back and select it again.
That's all you do. Yep. So we get plus the square root of 9. Now watch how I type this, because this is how you should do it. This makes it easier. 9 minus 4. Don't use parentheses when you're inputting it on your calculator. It just gets too confusing. So it's just 4 times 5 times negative 1. Just, you can multiply by negative numbers on your calculator, and it knows how to handle that. Scoot down to the bottom, divided by 10. If I hit enter, there's one of my solutions. Now Moodle's just going to ask you to round that, I think, to 3 places, so it would just be 0.239, right? To get the other one, what do, Noah?
You just go back up and select it and then change the
Good.
positive.
Yeah, select it, hit enter to pull it down for editing. I just want to change that plus to a minus. Now there's a little trick here also. If I have to go kind of toggle or trace all the way through the equation, that's a long time. I can skip all the way to the left or the right side of the screen by just hitting second left, for example. Takes me all the way to the left of the expression. Then I just have to go 2 to the right, or 3 to the right. Highlight the plus, overwrite it with a minus, hit enter, and look, now I've got both of my solutions on the same screen. Okay, so make sense? Okay, what would I do if, okay, what about this case? What if I had something like this? What if I had negative 2x squared plus x minus 7 equals 2x? What would my first step be?
Move the 2x over to the left side.
Okay, move the 2x over to the left side, for example. I could just subtract 2x from everything, right? Okay, and the reason we're doing that is so we can get a 0 over there, right? Then we end up with negative 2x squared minus x minus 7, okay? Is that okay? Seems like it. Seems fine. There is a problem with this, though. You don't want a to be negative. When you're using the quadratic formula and using a negative a, it's really easy to make mistakes, okay? So you always want to make a positive. So what's the one thing I have to do here if I have this in standard form to make a positive? Yeah, multiply or divide, however you want to think of it, both sides by negative 1. If I do that, well, negative 1 times 0 is just 0, right? So on this side, all that does is just change all the signs. So I get 2x squared plus x plus 7 equals 0. Now a is 2, b is 1, c is 7. Throw it in the quadratic formula, you're done. Okay, I'm not going to do this today. We'll look at maybe one quick example tomorrow. But do you see that it really wouldn't be a big deal if we ended up with a negative number under the radical? That's okay. That just means we're going to get i's in our answer, right? No big deal, though. Okay? Right? Isn't that great? So the song, just so you know, I'm sure you're going to want to go listen to it again. It's on the website now. There are some free apps for like pulling songs off of YouTube if you want to make an MP3 or something, which I'm assuming you all could probably want to do, right? Yeah.
Oh yeah, seriously, no.